A very important class of functions in the study of mathematics, physics, engineering, economics, really any of the sciences, is the class of one-to-one functions. And a one-to-one function is a very specific kind of function. Let me put up a definition. Okay, a function is one-to-one if each x value, also known as the input, corresponds to only one y value, which is also known as the output. And each y value corresponds to only one x value. Okay, so let's unpack this a little bit. What this means is that we can go backwards with a function. So one way to look at functions is kind of like this, right? We go from here to here. We can think of a function as kind of a mapping, right? A function goes, we'll call this x to y. And if a function is one-to-one, that means we can go back and get back to x again. When we do that, let's call this f of x going out to y. When we go back, this is called f inverse of, we'll call it y here. Okay, so this thing here is called the inverse function. Okay, this inverse function, we'll just say goes backwards. Okay, so that's the whole idea. We want to have functions that we can go forwards and backwards on. They allow us to do a whole bunch more stuff when we're looking at various different applications of functions. And the thing is about one-to-one functions, these have inverses. That's why we care so much about them. Now, we don't usually write f inverse of y because this over here, we're going from the real numbers to the real numbers again. So when we go back, we're going from the real numbers. So usually we write this as f inverse of x. We don't really say f inverse of y. We just say f of x going out and then f inverse of x coming back. So we usually write f inverse of x. And this does not mean, okay, it does not mean 1 over f of x. Okay, if we want that, we would write this, f of x, and then we put parentheses and we say all to the -1. Okay, so it's easy to get tangled up with that, but this f to the power of -1 of x means the backwards function, or the inverse function. Let's try an example. Okay, well this is a strange way of looking at functions, but this is one way to look at a function. Is a set of ordered pairs, so we essentially have x and y, right? X and y, x, y, x, y. This function says 1, 2, 3, 4, 5, 6, 6, 7. What that means is this function takes 1 goes to 2, 3 goes to 4, 5 goes to 6, and 6 goes to 7. That's what that notation means. And notice that every x value goes to only one y value. 1 goes to 2, 3 goes to 4, 5 goes to 6, 6 goes to 7. And every y value is hit by only one x value. There's no two different x values that both go to 2. There's no two different x values that go to 4. There's no two different x values that go to 6. There's no two different x values that go to 7. Thus, we would say this function is one-to-one. This one is one-to-one. Okay, let's look at one that's not one-to-one. Okay, so here we have g. G says 8, 6, 9, 6, 3, 4, -4, 4. Okay, so this tells us that we can see pretty quickly 8 goes to 6, but we also have that 9 goes to 6. Okay, so that's two different x values, both going to the y value. So if we try to go backwards, and we say, okay, now we want to go backwards. We start at 6. Where do we go? Do we go backwards to 8, or do we go backwards to 9? Right? This function doesn't know how to get backwards. It gets split. So this one is not one-to-one. Not one-to-one. Because we have two different x values going to a single y value. Just to get a little more familiar with how these functions work, let's just look at a one-to-one function. For instance, one of these might be f of x equals 2x cubed minus 4. Okay, turns out that one is one-to-one. So let's just look at this a little bit. If we take f of 0, all right, so I'm plugging in 0 for x, that gives us negative 4. What that means is if we went backwards and we said f inverse of negative 4, right, well, we'd have to get back to 0. Gets back. I'll say, how about this? Gets back where we started. Where we started. Okay, so f of 0 equals negative 4. So f inverse of negative 4 gets us back to 0. Right, same function, let's say f of, let's do f of 1. Okay, so I'm plugging 1 in here now for x. So that's 2 times 1 minus 4, so that equals negative 2. All right, so then f inverse of negative 2 must get us back to 1. We can look at it like this too. We put in 1. We get over here to negative 2. So that's our f. If we go backwards, f inverse, we put in negative 2 and we get back to 1. So f of x and f inverse of x. Okay, so there's a bunch of different ways of looking at inverse functions. The more you study mathematics, the more you study what it means for a function to be inverse, what kind of functions have inverses. So this is just a first introduction. This will become more clear as we move forward.